Welcome back to another session of Cloud Native series. And so far, we talked about how to set up Kubernetes cluster, what are different ways to set up Kubernetes cluster, and then how to secure the API access, right? Now, switching from the DevOps, the administrator role, from there, switching to the developer role, where we would understand today how we can utilize Kubernetes cluster, what things we can deploy there, and we'll understand at least the stateless applications, how to work with them when deploying or configuring them on the Kubernetes cluster. So that's going to be the target for today. And I'm Praveen Selector, engineering lead here at Inet. So the focus for today, as I said, it's going to be around deploying stateless applications. There are a few object types in Kubernetes: pods, deployments, DaemonSets, services. So we'll understand those things. For the last 3 sessions, recordings and blog posts and commands and everything else is available on inet.io. So questions for today are going to be around just understanding those Kubernetes objects related to basic applications or stateless applications. We'll understand what is a pod, which is also the minimum deployable unit in Kubernetes. We'll understand what are deployments. There is a specific object called deployment there. What are daemon sets, and then how those are related to pods. We'll understand what if we want to limit our applications to have resource quota in terms of CPU and memory. How do we limit them? Let's say an application is only supposed to use 100 milli CPUs and maybe 256 MB of RAM, that kind of stuff. So we'll talk about that. We'll understand how to access your pods or your applications within the cluster, outside the cluster, what are the different ways, and all those network related concepts using service, what are different types of services that you have, and then at the end, what are different important things to keep in mind while working with this kind of load on Kubernetes. So this has been the diagram that we have been following for last 3 sessions. We set the Kubernetes, or we installed the Kubernetes cluster on our AWS account. We understood these components. In the last session, we understood how to access securely from kubectl to API server. Today, the focus is going to be on this side about how to utilize your Kubernetes cluster. And that's where I said we will be switching from a DevOps or a SecOps or an administrator role to a developer role, because now it's in the developer's playing field about what type of applications we want to deploy there. If we understand that, then what is the configuration that we need to have in our applications so that those can be deployed in a Kubernetes cluster, how we can make our applications highly available, how we can make it securely to reach out to this particular applications via HTTP, TCP, or any other protocol that our applications are using. So that's going to be the target for the next couple of sessions. So before I start, just wanted to verify that I have my cluster up and running. So just using the same cluster.yaml that we had last time, I already installed the cluster with 1 master and 2 nodes. If you check here, it's the same. I have a bastion as well, 1 master, 2 nodes, all running in the same zone. It's of course not highly available master configuration, but should be sufficient for today's need. And I'm also using IAM to talk to my Kubernetes cluster. So you can see in this case, I have created 3 different contexts. One was created by KOps by itself. 2 other ones are actually using the same configuration that we understood last time using IAM. Let me just open it one more time. So here you go. It's using AWS IAM Authenticator. I have created 1 additional role though this time called admin, who has the full access, who is part of the system masters group. And last time, as we understood, the developer role is also here if you want to try out a few things there. Cool. So looks like the cluster is up and running, and I'm accessing the cluster as an admin. That means I have access to everything in the cluster, not just specific to a namespace or anything. So the first question is, what is the minimum object or minimum deployable unit that you have in Kubernetes? When dealing with Docker, any other containerizing tool, we deal with containers, right? So what are containers? If you remember the first session, we already gone through this piece. Very generic term, depending on the containerization framework or tool or technology that we are using, different sort of implementation, but ultimately your container defines what application you are trying to build and what is it and what are its dependencies, right? Docker, as we've seen before and understood, it's the most popular container runtime right there. There are others as well called Rocket or Open Container Specification as well. But then in case of Kubernetes, container is not the minimum deployable unit. In Kubernetes, you do not deal with containers directly. There is higher level concept or object called pod. And if you remember one of the diagram from the previous slide, this is actually a pod. What is a pod? Think of it as a basic building block of the Kubernetes containing one or more containers, or it may have a shared volume shared between the containers, and of course a local host or a networking IP as well, or the networking layer shared among the containers within the pod. So it is the smallest and the simplest unit in Kubernetes object model that usually a developer or a user who has access to the cluster can create. It encapsulates one or more application containers, maybe a WordPress and the database, or maybe your API and monitoring side container around it, or maybe your API and the logging driver around it, or something like this, right? So you can think from that perspective. They share the volume. That means they are sharing something like, let's say, a hard drive you can think about. And then also if A has to reach out to B, since both these containers are running in the same pod, they can reach out to each other using localhost or 127.0.0.1 because they are sharing the network IP as well. So in case of Kubernetes, a pod also defines how this container should be living, should be using resources, how much resources, what if one container goes down, who has the responsibility of bringing that up. Yeah, those kind of stuff is actually controlled by the pod, the minimum or the basic building block of anything in Kubernetes. So think of pods as container plus plus. Yeah, you have the capability of running multiple containers in a pod, which is not very well encouraged. There are very less use cases of running multiple containers in a pod. Cool. So if we understand that piece, that means minimal deployable unit is a pod. So the next question is, how do we tell Kubernetes that I have this Docker image, but what is the configuration looks like for a pod, right? So that is defined using a pod template. It's a YAML file. All the objects in Kubernetes world can be created using YAML files that you can keep with your Git for your particular project, and you can commit to your Git, you can version control, all that kind of stuff. So if you look at this particular YAML file, which is a pod template, kind is the property that defines what kind of Kubernetes object is this. In this case, it's a pod using the version or the API version v1, which is a stable one. Then we have some metadata options here about what is the name of it, if you want to provide some labels to this particular pod. And then we talk about how many containers you are running and what is the definition of each container within this pod. Now, this particular example here, I am running 2 containers, right? One of them is a specific image from a Docker Hub repository, and that is exposing a port 80. So that's a container port 80. It's actually just an Nginx-based application or a simple site, nothing more than that. I'm naming the port. You can name a port in a pod in Kubernetes world. It is helpful later down the line if you want to expose services to it. And then, of course, I want to make sure it accepts TCP, which is layer 4 protocol type of request coming to this pod on the port 80. So that's one container within this pod. The other one is I'm just running on Alpine Linux 3.8, and I'm just running one command, echo it, and then go and sleep for 3600 seconds. So in this example, I'm running 2 particular containers, right? So let's go. I have YAML files are already created. Let's go and apply and then see what's the life cycle of a pod and how does it work. It's the same example that I showed you before. I'm just going to go and then apply a file called pod.yaml, this particular file. So as soon as I do, and I'm in the dev namespace, then if I check the pods, I have one pod running called app. Why? Well, because the name of the pod was app. It has internally running 2 containers, and both of them are up and alive. So you can see 2 out of 2 here. And then, of course, it has been running for 14 seconds. That's how the pod is running 2 containers in this case. Do we have any logs? So we can check the logs using kubectl logs and the name of the pod. Now, one problem here that Kubernetes is telling, or kubectl is telling us, since there are 2 containers running inside this particular pod, you have to tell whether you are asking logs from whale, which is this container, or you are asking from Alpine, which is this container. So there is an option to pass the container name as well for which you want logs. So let me look it for the container whale, and I don't have it because it's an Nginx service. If no one accesses it, no logs. What about Alpine? Because there we specifically asked to log hello Kubernetes, right? That has been logged. So you can check the logs of a pod. If you have multiple containers within that pod, you have to specify the container. Otherwise, you can just use logs and name of the pod if it's only running one container. Now, when you run a pod or any other object, actually, you can always describe them. So I'm just going to describe this pod called app, which is running here. And then if you see good, nicely formatted exact representation of that pod in the Kubernetes API right now, current representation of that particular pod. So it has a name running in the namespace dev, running on this particular node. Remember, we have two nodes in our cluster. Started when there are no labels, what was the configuration applied for the first time, what is the status, what's the IP, and there are two containers, so all the details about those two containers in terms of where is the image, what ports are open, when it was started, how many times it has been restarted, and any secrets or anything else that has been mounted. This is the Alpine container. What's the condition of the entire pod, which is it is initialized, it is ready, it is scheduled, if there are any volumes or anything like that, and all the Kubernetes related events that has occurred for this particular pod, including scheduling it, then mounting a certain volume for default secret, creating both the containers, those kind of stuff. So you can think of describing is explaining what's the current status of this particular object. You can use kubectl described on any kind of Kubernetes object, not just a pod. Cool. Now we have seen how to access logs. If you want to go inside this particular pod, think of it like maybe if this particular pod was any VM and you want to SSH into that VM. So right now, using kubectl exec, which is similar to Docker exec allows you to enter into your container. Kubectl exec allow you to enter into the pod. But again, if you are running more than one container, you have to specify which container you are trying to exec into, right? And then you can run any shell, whether it's sh or bash, depending on what that container has. So in this case, I'm trying to interactively exec into, let's say, pod app, and I want to go into Alpine one. And I'm going to open a shell, and then I'm now inside the pod. So it's very easy. You can think how powerful it is because you didn't have to SSH to the cluster. No access to the bastion is required right now to do this job, or from bastion to your nodes and then figuring out where is the container and doing Docker exec. kubectl allows it very easily for you to directly access from your local machine and directly go into the pod or into the container within the pod. So I am there. Let's see what's happening here. Do I have netstate access? Yes. So in this case, you can clearly see, although I went to the Alpine container, right, which was not running anything like Nginx or anything on port 80 or 443. But remember, all the containers within a pod share the network. That means if this container has opened some port, this container can see them as well. It's the same network. So that's why, although I'm going into the Alpine container, let's say it's B, but ports opened by container A, which is Nginx base image, port 80 and 443, I can access it. Now the question is, can I then just do curl onto this localhost? Let's see if curl is even defined here. Alpine doesn't have curl, so I'm just going to add curl utility there. Now if I go and do localhost, which should go to port 80, and then you can see, that's an HTML page getting served. This is exact HTML page of Dockerville. Somewhere it has the host name of the pod as well, right, which is app in this case. Yep, so I can reach out to the other container from this container, and that's the whole point of pod, which can handle multiple containers within it, and networking is shared there as well. So we understood how to get a list of pods, how to describe them, how to get logs, how to go directly into the pods themselves or the containers if you have multiple, and then you can also see where this particular pod is running. So we have in this cluster 2 worker nodes and 1 master. Nothing will be scheduled on the master by default. That's a policy from Kubernetes. So all the workload will be running on worker nodes, not on the master. So if you ever want to see more details about where these pods and all these things are running, you can just provide this flag. And that actually gives you what is the IP of this particular pod and where it is running. So it's running on 64, which is this node. And looking at your AWS console, you can figure out what zone it is, how much memory it is, and all that kind of stuff. So pretty simple how to work with a pod, right? And hence, we can delete this pod as well. Once you delete, it's not going to be consuming any CPU memory. It will not be available on that IP. It will be evicted from your cluster. So it's going to take some time. It would be in the terminating status right now. You cannot reach out to pod app in this particular fashion because it's going down right now. Kubernetes is evicting out of the cluster. So that's how a pod goes down, right? If you delete, it's gone. You cannot get it back unless you go and create a new pod using the same YAML file. So that's where the problem comes. The first problem, fine, we were able to create a pod and run it through in Kubernetes cluster, but your pods, your applications, they are always susceptible to memory leaks, or maybe they will go down because of some errors. Maybe the nodes go down or whatever, right? You need someone who can take care of these pods, because if they are gone, they are not going to coming back on their own. That's where concept of pod controller come into picture. And the reason is because pods not self-heal. If they are deleted, they are gone. So you need a pod controller which can take care of the availability of these pods. If these pods go down because of any error or any issue, you need someone to bring them up. So there are few Kubernetes controllers that handles this kind of work, managing this pod instances. They create and manage multiple pod instances if you need. Let's say you need 5 instances of your application. So this kind of Kubernetes controllers can manage it for you. They can handle replication. They can handle rollout as well. Maybe you have 100 instances of the same application running and you want to roll out a new version of it because maybe it's a new release. You can release it in a fashion that it goes and update 10 instances at a time, or 5 instances at a time, or 1 instance at a time, and maybe have 10-second lag between updating the next instance and so on. So that's the rollout. You can do blue-green deployments kind of stuff as well. And of course, if a pod goes down because of any issue, pod controller will make sure that it brings it back up in the cluster. Maybe on the same node, maybe on a different node, depending on the scheduler or whatever kube scheduler is recommending. So there are 3 specific type of pod controllers that we will be talking about today and the next session as well. The first one, the easiest one, is the deployment controller. And that takes care of simple replicated pods. I would suggest using it for most of the stateless applications. The whole point is you say, I need 3 replicas of this particular pod. You tell it to deployment. It will make sure there are always 3 replicas of that pod. The idea is to maintain the desired state. There's another controller called DaemonSets controller. Same point, the only thing is maybe you want to specify to run one pod on each of the node in your cluster, right? Like a daemon process. So that's a DaemonSets controller. You can specify what type of nodes. Maybe you want to run it on a master node, maybe only the worker nodes, or maybe set of the nodes. You can do all those kind of node selections for the DaemonSets, usually used for logging, monitoring drivers, or including the authentication module that we used before, AWS IAM Authenticator. That is actually deployed as a DaemonSets. AWS Authenticator is installed in kubesystem namespace. So you see this guy? That is deployed as an DaemonSets. The idea of the authenticator is to run one copy of the pod on each master node. You see the node selector? It's asking run one copy of AWS IAM Authenticator there. Since we have only one master, only one copy of it is running. On the other hand, KubeRouter runs on every node in the cluster. One copy of KubeRouter pod on each node in the cluster. So there are 3 nodes total, including master and the worker. So there are 3 pods in this DaemonSets running on one on each of the node. And then the last one is, what if, let's say, you want to have stateful apps, meaning each pod having a dedicated volume, and then you want to have multiple such kind of pods. Think of your highly available database. Maybe you have a Cassandra cluster, or a Spark cluster, or a Kafka cluster. Whatever you can think of, all these heavyweight stateful applications which are storing something, you can think of stateful set. Stateful set is something that we'll cover in the next session. Today, we will be talking about deployments, DaemonSets, and then a way to reach out to these particular pods from networking perspective. Another thing with the stateful set versus deployment is, in case of deployment, let's say if you say, I need 5 replicas of this particular application, deployment will go ahead and create all those 5 replicas at the same time. In case of stateful set, it will go and create one by one. In case of stateful set, it's going to provide you an ordered rolling update and scaling. So it will go and create one first, only when it's alive and up and running, then it will go and create a new one, then the third one and the fourth one and so on. So that's one of the major difference between stateful and deployment. DaemonSets is a completely different process because that's not requiring you to specify replicas. That's requiring you to what set of nodes that you want to run. So let's go and understand deployments a little more because, again, the question is, we understood pod template. How does a deployment object look like from YAML perspective, right? What properties are there? So the whole idea, again, is you use deployments for your stateless applications. It provides a nice and declarative model for your pods. Internally, it uses an object type called replica set, which maintains the same idea about what's the desired state, how many replicas you have asked for, and if you change anything in that pod template, a new replica set is created. We'll see an example. Now, if I go back to, let's say, deployment, let's see how does it look like in terms of YAML configuration. So again, kind is the property which separates a Kubernetes object from another. In this case, kind is deployment. I'm naming the deployment to whale deployment, and then the spec starts from there. The first thing is, okay, how many replicas do you want? So I said 2. We'll come back to this. Let's focus on the template portion right now. Doesn't it look like similar to pod from here? Right, so I have 2 containers, right? And if you see here, in the spec of the template of the spec of the deployment, these are the same containers. Then the question is, for these 2 containers that I'm running, how I want them to be named, right? Or located or selected. In this case, I'm just giving them some label. So I'm saying, okay, these are my two containers. Run them together in a pod. Label them with this label. You can think of any arbitrary key value, which will allow you to identify your set of pods. So I'm saying create a label called app. So this entire template is just the pod template, except, of course, the kind and the meta API version around it. And then I go and say, create two replicas of this. So the job of the deployment is to create two pods because I asked for it. And then another thing is in your Kubernetes cluster, you can have multiple pods running at a time. How a deployment object is going to make sure you have always two running? Well, it will just go and continuously query your Kubernetes cluster for all the pods having the label app with the value whale app. If it finds two, fine, it will be sitting there silently. If anything less than two are available in your cluster, it will go and create one more. So we'll try this. So I have this deployment. So let me just go and apply this deployment now and see what happens. So it has been accepted. Let me go and see how many pods are running. So now you can see there are two pods running. Why? Because I asked for two replicas, right? And both of the pods, which are named after the deployment, are running two containers, same two containers that we had before. If I go and check the deployments, you will see the whale deployment is there, which is this guy. Two I asked for. The current status is there are two pods running, two up to date, two available, and it has been running for 25 seconds. And as I said before, internally deployments uses an object called replica set to manage this desired versus current state. And this is what the replica set does. So that's actually a deployment where you can specify how many instances you want of a particular pod. The next thing is, let's talk about self-healing. So I'm going to go ahead and kill this particular pod manually. So I'm just going to say, you know what, delete this. And let's see here what happens. Yeah, so I deleted the one, but Kubernetes deployment actually detected it. So since I have executed delete, so of course it's terminating by the same time, it brought up this particular pod, right? 7 seconds ago. The whole point of a deployment or any other pod controller is to make sure your desired state is actually the current state. So that's the whole job of deployment, which is using replica sets behind the scene. Now, what if, let's say, you want to scale your number of pods for a running applications, for a running deployment? You can do it in two ways. There is a command that you can execute to scale it directly on a live cluster. You are saying here, oh, scale the deployment, name of the deployments from whatever it was to this new count. Let's try that. So let's say scale deployment. What was the name of the deployment? Will deployment. Replicas, I'm going to scale it to 5. And in this case, let's go and check. And you can see now, immediately 4 seconds ago, 3 new instances were deployed because 2 were already running and 3 were added because I asked for 5. Whole point is to make sure your desired state is the current state, right? That's how it's taking care of those pieces. So you can scale it from there, or if you want to update here and then do apply, you can do that as well. So that's how both ways you can handle it. Let's go and describe a deployment. Same story here as well. It will have the definition of the deployment when it was created, the initial configuration, replicas, how many are desired, updated, available, and all that. And then it has the templates for the pods. So 2 containers, right? Alpine and whale, different images, and then all the events and everything related to that. So that's a describe. I can also edit a live deployment using Kubernetes edit command, which you can execute on any kind of objects. So I'm going to go ahead and edit it, and you can see this has more properties than you put initially in your file, because remember, this is representing a live running deployment, and Kubernetes internally will manage and put a lot of other properties as well, because this is the representation of that running deployment. So it has the link, it has the UID there, how many revisions it can have in terms of what if you change the image and all that stuff. It's storing the current set of replicas and what's the current status of it, right? All this kind of events and properties available to it. And let's say in my case of deployment, I had an environment variable there. So you can pass environment variables to your containers using this particular fashion. And here you can have a list of environment variables with name and the value. Name, I have put some environment var, and the value is awesome. So let's go and change it to maybe something like again. So I'm editing our live deployment. Let's see what happens as soon as I edit. It will be edited, and since I edited the deployment itself, it's going to terminate the current pods which are running because I have changed the status of it, right? Or something inside the pod template. Maybe it's an environment variable, maybe I'm updating the image of it, the Docker image for that particular container or multiple containers inside the pod. So it's going to launch new one and terminate the old one. Let's go inside at least one of this pod and see if the environment variable has been updated. So I can exec into this pod, and this is again running multiple containers, so I have to specify the container name, and I'm in. Let's just execute this, and yep, here it is. The environment variable inside the container has been updated because it's a brand new container, right? Kubernetes actually destroyed the old ones and started the new ones. And that's how Kubernetes manages your different versions of deployments. So if you go and check replica sets, you can see there are two versions of it. This was the old version. This is actually the new version of the deployment. Why new? Because I edited the pod template. Unless you are only changing the number of replicas for every other change that you do on pod template, maybe you are changing any environment variable, maybe you are changing any port configuration, maybe you are changing a Docker image version there, a new replica set will be created for each kind of that scenario. And this is the current one. The old one is still there, but nothing, no desired, no current, no ready. This allows you, what if you want to roll back to your deployment, right? There is a simple command to roll back to the previous replica set because maybe this is not working out or this has gone with some issues in production or something like this. So you can always switch or roll back to the previous deployment using replica set revisions. That's how easy it is to work the deployments. There is this entire spec that you can go through it and understand what other properties are available. The next controller that we have is called DaemonSet, right? We already understood some pieces of it. What if, let's say, you want to run one pod per node in your cluster? That's where DaemonSet can be useful. Just the name daemon explains something. You want to run a process on each particular node. And that's why it's mostly used for maybe you want to collect logs from all the pods running on this particular node and ship it to maybe Elasticstack, maybe Logstash, right? Maybe you are monitoring, you want to deploy one pod of Prometheus to monitor all the pods on that particular node and then collect all the metrics and send it to Prometheus database, or maybe you're using Influx there, all that kind of stuff, including the authentication module. If you remember, I showed you AWS IAM Authenticator. That is running on only the masters. So you can even select set of nodes to run your pods. And that's how you do using DaemonSets. Again, the same idea, maintains desired state defined in the spec. So let's go and check an example of DaemonSet. Almost same template here compared to the deployment. The only thing changing is outside this pod template. So here we say replicas 2 in case of deployment. In DaemonSet, we don't say how many replicas you need. The whole point there is you have to tell on what type of nodes you want to run it, right? And the selector is still the same. So that's it. There is no concept of replicas here in DaemonSet. So let me go and kill this deployment for the time being. Again, if I kill the deployment, no one is going to bring back those pods because I'm killing the controller itself now. Okay, that's gone. And all the pods will be terminating as well. That's one of the life cycle stage of the pod terminating. So how many nodes do we have? We have 3 nodes. This time we want to run a pod on each one of them. Remember before, in the old state of the deployment, 3 of them were running on this node and 2 of them weren't running on this node, right? Let's apply the DaemonSet now. Again, remember, there is no replica count here. In this case, I am telling deploy one copy of this pod on all the available nodes. And how many nodes do we have? 3, including master. Let's see what happens. So I have only 2 running in this case. How many nodes do we have? 3. So what's happening? Let's check the status of the DaemonSet as well. And it says, I only asked for 2, but that's not true. I did not even ask for any specific number of nodes or any specific role of the nodes. So what's happening here? Why it's telling I have asked for 2 while there are 3 nodes? Again, remember, in case of Kubernetes cluster, masters do not accept workload. Master nodes are tainted. So if I go and describe the master node, it has a taint to not schedule anything on the master, right? So taint influence scheduling on whether you can deploy anything on this particular node or not. All the masters have this particular taint, and kube scheduler looks at it and say, oh, okay, I cannot deploy anything on the master because it has this particular taint. So that's why there are only 2 pods running. Where are those running? I can check using override, and they are both running on different nodes. Makes sense because that's a daemon set we are talking about, right? So 2 were asked because there are only 2 nodes, and we want to deploy 1 pod on each of the node, just like a daemon process. Pretty simple. Now, that's where another concept comes. Okay, what if you want to run your workload on a specific set of nodes? And how do you define this specific set of nodes? Well, if you go back into the describe of the node that I did, in this case I did on the master. So there are a few labels. There are a few default labels. You can put more labels as well. And you can create a node selector property on your pod and tell, you know what, deploy wherever the node label is this, or wherever the node label is this. Maybe instance type is M5 large. Maybe you only want to deploy it in the USTS 1 A zone or 1 region, or maybe you want to even deploy it on a master or only on where the role is node, right? Those kind of stuff. So that's where node selector property comes into picture. It allows you to schedule your pods, whether those are from deployments or from daemon sets or from stateful sets, and a specific set of your cloud provider's virtual machines. In this case, we will be using AWS. So you just put a node selector in the pod template itself, and then you can pick any range of labels from the nodes. What Kube Scheduler will do, it will go and find out nodes which have this particular labels with those values, and it will just deploy it there. So daemon said here, we didn't say anything, so it deployed only on the nodes because master don't accept workload. So let's influence and tell it to deploy it on the master only, just like what AWS IAM Authenticator is doing, right? So how do we do that? So just here, 2 things we have to do in the pod template. First, since it's a master, I have to tell, okay, find out the node where there is a label called this, which is actually on all of the master, and this is the value of it. So we are first selecting the node which we need. The second thing, since masters have this taint of not accepting any workload, we have to tolerate that particular taint. So taints and toleration. So there is a page on kubernetes.io just to explain these 2 things. This scenario, maybe you have different AZs and you want databases to be deployed or workload or related to a database deployed in US 1 East A, 1A, or maybe your application is in 1B. You can achieve all that kind of stuff by configuring node selectors with optional toleration. Let's try it out. Here I'm saying look out for the master nodes. We only have 1 master. And since it's a master, we have to make sure we accept this taint as well using this toleration. Otherwise, it will not deploy. So let me kill the current one. So, okay, both of them are terminating. And you can see they were running on the nodes only, or the worker nodes. Let's apply the daemon set with the node selector asking only to deploy it on master, and since those are on master, I have to accept the taint using this toleration. Okay, now you will see only 1 container is getting created, and if you check where it is getting created, forget about this 2, only the 1 running, it is on 114, and if you see what node is this, that's actually a master. So that's exactly how AWS IAM Authenticator is deployed using this particular node selector and toleration. So pretty much you can do it, this kind of configuration on any controller, whether it's deployment, whether it's set full set, or maybe even daemon set as we have seen here. These 2 properties are actually on the pod template. You can even do it on the pod template itself if you are dealing directly with the pods. So there was a daemon set. So far we understood pods, deployments, daemon set, and now node selectors as well. Easy. The next question comes, fine, we understood how to deploy, how to replicate, all this is good, but what if we want to limit CPU, memory, storages for the containers running inside pods? Because you want to get away from out-of-memory leaks, right, or those kind of overutilization of your cluster. Or maybe sending entire virtual machine or node into out-of-memory error. If your applications keep on consuming memory, they will ultimately crash entire virtual machine for that matter. So you can use a resource quota on the pod template that can provide you a constraint that limit your aggregated resources for your CPU, memory, storage, or even if you apply it on a namespace, you can limit all the pods running in this namespace, use this amount of CPU or memory, or this is the total number of objects you can create in this namespace and all that kind of stuff. So you can apply it onto a namespace. I'm not going to go into there, but details are available how to do that on namespace. use case, maybe let's say you have multiple environments in the same physical cluster. Using namespaces, you have created a dev environment, maybe a staging environment, and you want to limit total consumption of CPU and memory for dev. You can limit it using this resource quota. You just go and create what's the total size of this namespace you should be having, CPU and memory, requests and limits, and then each pod you can specify, okay, how much this particular application should be consuming. So let's try that. So on the pod template, you just have to specify resources in terms of what you are requesting right now and what should be the allowed limit. So of course, you should always have limits equal to or more than the request. So the idea here is I'm only going to be specifying how much memory a node should be having in order to accept this pod. Again, influencing the decision by the kube scheduler. I'm asking for wherever your kube scheduler is deploying this particular pod, make sure, this is the request, make sure it has 64 MB of RAM and at least 250 milli CPUs. So that is a definition of one CPU. If you are on AWS, it's actually equivalent to one vCPU of your EC2 machine, one GCP core if you are on Google Cloud, one Azure vCore if you are on Azure. Here for the memory, again, you can use kilobytes, megabytes, gigabytes, terabytes, petabytes, or exabytes. You can specify how much minimum requirement you have for this particular container. Then you can tell Kubernetes, you know what, I'm asking only 64 MB of RAM right now, but let it grow until 128 MB of RAM. And once it reaches there, kill it. And that's the whole point of specifying resources on your pods or containers. Same thing goes here as well. I'm asking only 250 milli CPUs. So that has to be the minimum requirement, but I'm asking Kubernetes to let this container and the pod grow to 500 milli CPUs, meaning half of the CPU, wherever this particular pod is running. This is very helpful if you are running very compute intensive or memory intensive tasks and you think that, okay, things may go down because of memory issues and bring entire cluster or nodes with it. Just specify these limits. Of course, in order to come up with these numbers, you have to observe memory and CPU utilization of your applications over time and then start putting this type of restrictions or quota on your particular containers inside the pod. So one important thing here is your CPU and memory values that you put here, they are absolute. They are not relational or proportional to the size of the cluster, meaning if you are asking 250 milli CPUs, even if you have one node or 100 nodes in your cluster, it's going to be the same exact value, okay? 250 milli CPU, and the definition of one CPU is defined here. Same thing goes for the memory as well. Now, as I said, resource quota is actually for containers, not for the pods. So you define these limits on the containers. That means if you have one container in a pod, it's the same thing, whether you're talking about pod resource or container resource. But if you have multiple containers in a pod, then you have to make sure all of them are having resources and for the requests and the limits properly configured. You add all of them together, and that becomes the resource quota for the pod if you have multiple containers. So pretty important thing if you are going to be running resource intensive tasks or applications on your cluster. Because if you don't do that, your application will keep on growing in terms of memory and CPU resource requirements, and ultimately it will bring down the entire node. And depending on what that node is, it may bring down other type of applications as well and may bring down your production. So make sure you understand this concept. So far, we have understood how to deploy and maintain multiple replicas, whether the same node, different nodes, one per node, all this kind of stuff. And also how to specify the resource requirements as well. The next thing is, fine, everything is good, but we usually develop web applications which are listening either on HTTP or TCP at least. If that is the case, how do we even reach out to those particular pods that we have running? Because right now I am running this particular pod, but I can't reach out unless I am inside the pod itself, which is useless. I want to access this particular Nginx app from outside world, or maybe within the cluster, or maybe from a different node and all this kind of stuff. So that's where services come into picture. Very important concept that you have to go through when you are developing RESTful APIs or any kind of web applications which will require accessing on HTTPS, TCP, or any sort of networking. So again, the whole point here is this is a different type of object that you can create in Kubernetes API. It targets specific set of pods. So again, the same concept here, you have a pod selector, and then it can provide a policy about how you can send requests on what ports and how to do load balancing internally if you have multiple pods and all that kind of stuff. So that's the whole point of a service. It provides a very nice abstraction or something called virtual IP or VIP based network bridge if you have multiple pods. Well, I want to run 5 instances or 5 replicas of this particular application, but you want only one DNS entry of it. And then internally, whatever that DNS entry is, should be doing round robin or whatever fashion among those 5 stateless applications. So that's where service comes into picture. You remember kubeproxy, the virtual IP-based routing? That's a responsibility of kubeproxy. In case of Kubernetes, services do not do round robin. There is a description about why they don't do it. There is some valid reason why they don't want to do it. So how do you create a service? Pretty simple. You just define another object of the kind service with the v1 API. You name what kind of service is this. Then you say, okay, what are the pods that you want to target from the service? So you just use a selector. You can use any labels that your pods have assigned. In our case, we were using the name app. Value for that particular label was well app. Important thing is the port binding. So here I'm saying start accepting connection on port 8080 and then send it to the container ports 80. And it is a TCP load balancing that it has to do or a service has to do. That's it. That's how you define a service. So let's go and check the service here. So it's a service, selection of the pods that will sit behind this particular service. I'm saying select all the pods where app is equals to well app. We may be having a daemon set right now. I'm just going to delete that and bring back our deployment because that was having multiple replicas, right? How many replicas we were having? Oh, let's do 5. So yeah, the daemon set pod is going down, but 5 new pods are coming up in this deployment. Yep, all of them are running. But I can't access, although they are all running Nginx, I can't access them. So what's the way to access? Create a service in front of it. Now I just want to make sure that all of the pods are having the label app equals to well app. That means this service will be able to redirect traffic to the port 80 on those containers. Remember, your container port has to match. So container port is 80. That means the target port has to be 80. And then of course you have a port where the service will be listening and it's going to do TCP redirects at layer 4 of OSI model. I'm just going to do apply F service. It's going to create a new object of the type service, and there is a command to list those. So, yep, you have one service of a specific type. We'll talk about a few specific types here. It has its own IP, and then it is listening on port 80 in this case. Now, what pods this service is selecting or sitting in front of it, you can use another object, internal object called endpoints, which lists a service name and where are those pods. So you can see there are total 5 pods, 3 and 2 more. You can actually describe this, which will tell you all the pods IP addresses. Because the whole point about endpoints and services, let's say you have these pods, 5 of them, and they all have these IPs, right? But if one of the pod goes down and a new one comes up, the IP will change. So your service and the endpoints, they are always looking for the selector. They are always evaluating the selector that you have defined here. And they will be refreshing the internal routing tables with the new IPs or the ports if something changes. And that's what you want. You don't want to hard code anything with respect to the IPs or the ports, especially not IPs. If ports are fine, but not IPs in this case, right? Because you can't control which pod will be running at what particular IP address and all those kind of stuff. And that's the beauty of this service discovery that comes from Kubernetes services. So you can think of this here. You have 5 pods running with different IPs. And if I kill one of them, so I'm killing the 13 one, right, with the IP 13. This is where it was. As soon as this particular pod is deleted, endpoint, which is always looking for pods using that selector, will find out, oh, this IP is no longer active for this particular pod. It will remove it from the list and add whatever the new pod is coming on. This is required. Otherwise, you would need some manual process to update the list of available pods and their IPs, right? One more thing here. So this is a new object that has been created, and kubeproxy, as soon as you create a new service object, will be configuring all the routing, where those pods are, and everything related to how you can reach out to those pods. Now let's evaluate or figure out, okay, how I can do round robin between these two. So far, I cannot even access this service outside cluster because it's an internal cluster only accessible service. I can still do it. I have an Alpine pod. I'm just gonna run this, and within the pod, I'm going to talk to the service using the name of the service and see whether it does round robin or any kind of that stuff. So let me apply. this particular pod. This is just to access all those pods using the service from some other application. Think of it like you have a UI app and you have a backend API as well. There are 5 replicas of the backend API. Think about this, right? I'm just going to create a UI app like this. This is just a pod. I'm going to exec into that. And it's a single container anyways, so I don't have to use C flag. There is no curl here, so let me install curl. Because I'm inside the pod right now, think of it like a very small virtual machine. And then from there, I can just use the name of the service, which is this. And let's see what port I have to go. I have to go to the port 8080. Let's see if it does any kind of load balancing between 5 pods. We have this pods, right? 6H, MT, N8, W7, ZC. So the first one is coming from 6H, second one GC. You can see all these here. So think of it, what's happening here? Everything else is same. This is just using the host name, replying back with the host name here. But as soon as I'm just looking at the service and a specific port, I get a request from a different pod every time, right? And that's the load balancing that the service is doing among these 5 pods. So think of this 5 as representing your APIs, and this may be just a UI app that you are trying to make a request, but you don't have to know where these are deployed, where are those IPs, anything else. You just talk to the service, and that will do load balancing in this particular case. So that's how easy it is. The question is, what was that cluster IP thingy? This guy? It says type equal to cluster IP, and looks like that's the default because we did not specify anything related to type. Cluster by IP being the default one, it exposes the service but only to the internal Kubernetes cluster. You still cannot access this service or these pods from outside world. If you are within the cluster, you can access it. And how we went inside the cluster? Well, we went into another pod, and from there we tried to access this service, right? So that was the use case here. So in this case, I was going in using the proxy or going into the cluster via other pod, and from there I was talking to the service, which was doing load balancing between 5 instances of a Will app. So that's a cluster IP. What other options we have? We can also have something called node port service. What that does, so let's say we have 3 nodes or 5 nodes, worker nodes. It will open a specific port that you define there when you set type equals a node port on that service. You also have to define optionally. If you don't define, Kubernetes will choose that port between this range. But if you define, it also has to be in this range. And then what Kubernetes will do is it will open that port on all of the virtual machines. And then you can reach out to those node IPs, call on that particular port, and that will internally go to the service and do all this kind of stuff. You can easily see issues with this type of service because now you have to figure out IPs of the nodes. And in our case, if you remember, our cluster or all the worker nodes are in the private cluster. That means it will be very much a lot of management in terms of maybe putting a load balancer in front of these virtual machines manually and then configuring it for this particular port. But what if the developer decides to change the port? Yeah, he will have to involve admin team again to change the load balancer configuration and all this kind of stuff. Of course, you can easily see it's not recommended because it has administration or the networking headache, every service that you create of this kind of stuff. Cool. You don't want to deal with all this. So what's the option if you want to allow external traffic from outside our cluster, maybe from the public-facing internet, to reach out to our pods? There's one better service type available called load balancer. Using this, you can actually expose your pods to the world. And what Kubernetes does, if you use type equal to load balancer in your configuration for the service, it will actually work with the cloud provider using the CCM, and then it will create a new load balancer on that cloud provider. So on AWS, it will create a new ELB, Elastic Load Balancer, Classic, and then it will manage even the life cycle of that particular load balancer. So if you have the service object with the type load balancer, it will create a new load balancer. If you delete the service object, it will delete the load balancer as well. So the whole point there is you can now reach out from the external world to that load balancer, and from there it can go directly to the service and then to the pods as well. So let's try this one because this looks interesting and of course very powerful as well. So let me get rid of the old service. What was the name? Will service. Here I'm just gonna say type load balancer. Again, remember, we have not provided any kind of information to it, right? We are only saying, okay, I just need a load balancer type of service. how does it talk to AWS under the hood? How does it even create the load balancer? Right now, there are only two load balancers running, one for your Kubernetes API, one for your Bastion. And let's see what happens in this case. So let me just go and apply this service now. And as soon as we apply, if you do get on the service, you can see a load balancer has been configured. It will take some time to bring it up, but if you go here, you'll see a new load balancer coming up, this one. You can also see why it was created and which particular service, the namespace and the name of the service, and what port you are supposed to send request to. Remember, port 8080. Internally, it has chosen some random port for forwarding to that service, and then from there it will go and reach out to the pod. So there are still 0 of 2 instances. Why 2? Well, from AWS point of view, it only knows nodes, EC2 machines, and there are only 2 EC2 worker nodes that we have. So it's waiting. It will take some time, but then at least it has this URL, and you of course want to make sure you go to port 8080. So it will take a few more seconds, still waiting for it, but it's Kubernetes job to configure and manage the lifecycle of this particular load balancer now working with the cloud provider. So that's a pretty good approach. Of course, you also can create internal load balancer or a private load balancer, because by default it's gonna create public facing load balancer or internet facing. Maybe you want to create a private one only. Maybe you only want to reach out to it from your VPN, or maybe within the cluster. If that's the case, there is a simple annotation that you can tell. Let's say in AWS, you can put it on the service and tell it to create an internal load balancer. Always useful if maybe in a dev environment or in a staging environment, or you only want to be reaching your services from VPN or from your private network, not from the external or public facing side. So that's how you can maintain that as well. Right now, this is an internet facing load balancer, and it's gonna put it into the public subnet, and it will open it to the utility subnet it was named when we created the cluster using KOps. But if you make it private load balancer, then it will put it into the private subnets, similar subnet which is hosting your masters and the worker nodes. So that's the whole point. So it looks like both of the instances are up and running. So let me go and refresh, and yep, my awesome Nginx app is running. How many pods do I have? I have 5, right? This one. You can see the host name here changing anytime I refresh. This is doing perfect load balancing. But using load balancer, ELB, I'm able to reach out to that service first on this port, and then service is doing internal load balancing between those pods. Cool. So that's the whole point of a service. There is one disadvantage of using load balancer, because if let's say you have 100 applications and you want to expose all of them in your production server or maybe somewhere in other environments, you may end up having 100 load balancers if you go with this approach, and each load balancer costs you from every cloud provider. So you should not go with this approach if you have many services that you need to be exposing either to the private or even to the public world. What's the solution? In the 2 sessions from now, we'll understand ingress controller. That's the solution which will minimize the cost by keeping only one load balancer for many services. But we'll come back to it. Right now, if you use this fashion, you will have one load balancer created per applications, per service, I should say. Then there is a last type of service available if you want to have just simple CNAME redirect. Think of a scenario, let's say you have a database which is not hosted in this Kubernetes cluster, or maybe you have some external URL that you don't want to configure for all the pods, all the applications. You just want to create one nicer name, but you just want to create a redirect internally. And that's a simple external name service type. You can see there is no selector, nothing, no ports. It's just saying whenever someone says whale service, I will do a CNAME redirect to wherever this URL is pointing to. To make your pods configuration now easy, they only have to understand whale service. Maybe your one pod want to talk to other pod without knowing whether that other pod is in the Kubernetes cluster or maybe somewhere else completely. Maybe it's an RDS instance, maybe it's a Redshift, right, on AWS, which is not part of the Kubernetes cluster. You can pretty much use this kind of external name service type as well. Very helpful, but only helpful when you have apps which are external to your Kubernetes cluster. So that's the last type of service that we have. A few things to remember, quickly going on to it, what we learned today. I would suggest running one container per pod as the preferred way, unless you have a very strong use case of running multiple containers inside the same pod. Do not directly deal with pods or replica sets. You should be using higher level controllers like deployments, DaemonSets, stateful sets. Because if you deal with replica sets and pods directly, you will have to manage and maintain a lot of stuff. You don't have time for it. Automate everything. Avoid executing or executing directly into pods, especially in production, because if you start installing all these arbitrary packages on those running pods, you may end up killing the process and losing the pod, or maybe you install too many things there on a running pod that it can explode or maybe exceed your resource usage, and then Kubernetes will kill that pod. One more thing that you will see here is every time I'm creating some object or submitting that object to the Kube API, I'm using apply. There's another command called create. I would suggest use apply instead of create, because when you use apply, Kubernetes internally can have in-place updates as well next time you apply again. While with the create, it's not possible. Either you have to do kubectl create for the first time, and then subsequent times you have to do kubectl update. So if you want to be just like idempotent, I would suggest using kubectl apply for every time you want to create a new object and if you have a YAML file. Deployment should be preferred for if you have stateless apps, or even if you have a single replica app with a volume. Think of, let's say you are using WordPress site, but you only want one replica of that. If that is the case, WordPress site need a volume, right? But if you only want one replica, deployments are fine. If that is not the case, and if you need multiple replicas with dedicated volumes, stateful set is the way to go. Make sure you keep on observing your app's resource requirements and then set your resource quota for your applications or your pods, containers within the pods. It's very highly recommended. Otherwise, even a stupid application over time can kill the node by exceeding even the node CPU and memory. So make sure you understand this piece as well. And then if you are having 4 types of services, what is the preferred order of if you want to expose your services to the public internet? I would suggest cluster IP with ingress, which we have not looked into today, is the best option. Then if that is not available, go with having a load balancer type of service for each service that you have. If that is also not available, then you should go with the node service, but I would say not think about that if you are already on a cloud provider. And the last one is cluster IP, which is only for the internal or the private ones if you want. If you are using node port service, let Kubernetes decide the port and you don't do anything with it. That's the point. If Kubernetes decides it, it will be random port, and that's why I would suggest not to use node port. Use XLM services, anything that is external to the Kubernetes cluster, so that you can manage all the DNS entries at one point for those external databases, external URLs, whatever you have. And your internal pods don't have to change configuration every time something changes on those URLs, so that's easier to handle that way. So that's what I had for this particular session. We went through understanding containers or pods, how to run single container in a pod, multiple containers in a pod, how to do resource requirements of the pod, node selectors, then how to have replica sets, deployments, daemon sets, and different type of services, including load balancers. So we covered a lot of ground today. The whole point today was, okay, as a developer, how do I utilize my Kubernetes cluster? I was given access by my admin, but I don't know how to run it, right? So today we understood that. So that's what I had for today, and talk to you next Thursday.